Hello everyone and welcome to MV Tutors. I hope you are good. Paper 2. I actually haven't really gotten a good look at it. Actually haven't looked at it at all. Thank you for those who participated in the poll. Let me just see. Let me be shocked with you guys as to what's happening here. Paper 1 was quite okay. Please don't excuse the background noise. We are at church, bringing it to church. Okay, so it says here, the table below shows the monthly salaries of 100 employees at Adams Law. Right, so we're seeing the monthly salary in thousand rands, so from 0 to 10,000, the number of employees, and then the cumulative frequency. Okay, so now 1.1 says, draw an archive, the cumulative frequency graph, to represent the data given in the table. Okay, so firstly we need to look at the cumulative frequency. So let's just fill that in and then draw the archive. Okay, so here we have 3 plus 4, that's 7, plus 13, that's 20, and then plus 20, that is 40, and then plus 21, that is 61, plus 12, that is 73, plus another 12, that is 85, plus 8, that is 93, plus 5, that is 98, plus 2, that is 100. Okay, so there we are. Now let us draw this archive. So we're starting with point 0. Remember, with an archive you always start there at 0. Okay, and then the next one we have 3 for between 0 and 10 rand. Okay, so we have 3 at 10 rand there, so somewhere, if this is 5, 3 must be somewhere around there. Okay, and then there's 7. Alright, 7, this going up and down for 20 rand, ne? So let's just do that. 7 is somewhere around there. I don't know if we should, no, if we label it, we're not going to finish. Okay, and then 20 and then 40. So let's just go to 20 for 30 rand, 40 for 40 rand. Okay, and then we have 61 and 73. So 61, probably somewhere there, and then 73, we are somewhere there, ne? Yes. And then 85, 93, so 85 should be somewhere there, and then 93, we are somewhere there, we're almost there, and then 98 and 100, so 98, ons is daar, and then 100. There we go. Okay, so it's sort of like a perfect one there. Now let's try to sketch this archive. Okay, so we are doing it. Oh my goodness. Okay, let me start from the bottom and then we'll meet somewhere. Ooh. Okay, this is a little bit harder than I anticipate. Oh my gosh. Okay, let's see where we are. All right, this will do. Okay, so we've drawn the archive. That's 4 marks. That's a nice 4 marks. And then for 1.2 says use the archive to determine the number of employees that receive less than 35,000 rand per month. So 35,000, we are looking, let's see, 35,000, we are there. Okay, it's sort of like close to like 30. Maybe I would say 29, because it's just, I mean, this archive is not really drawn to perfection. So yeah, I think 29, 30 should be good. So the number of employees that receive less than 35,000 rand a month, I would say around 30. Okay, you can't really say approximately 30, but yeah, let's just go with 30 employees. Let's be confident in our answer. I think they would also be fine with 29. Now determine the median of the data. Okay, median, we are like halfway, ne? So this is us here. I'm not using a different pen. Let's try maybe a highlighter. We're somewhere there. Okay. Ish. See, I think I've not drawn to scale proper. So it's roughly 45,000. So that I would say that's the median of the data. All right. So 45,000. Taking you guys to church today. Okay, now 1.4 says the monthly salaries of the 5 employees in the interval between 80,000 and 90,000 are given below. So these are the actual salaries, right? And then it says 2 employees from the interval of 70 to 80. Let's see, from 70 to 80,000, what did we have? 70 to 80, we had 8 employees, right? So 2 of those employees are promoted and receive monthly salaries of 83 and 84 respectively. Okay, so now we are left with what? We are left with 2 of them are gone. They've received a promotion, and now we have 7 here, ne? Okay, so now determine the mean monthly salary in the interval between 80,000 and 90,000. Okay, so we're literally gonna take all these values. Okay, all right, so this is 84 plus 85 plus 87 plus 89 plus 89. I should have said 89 times 2. And then we have 83. Oh, that we might get increases as well as working people. Okay, promotions, ne? 1, 2, 3, 4, 5, 6, 7. So we have 7 of them now. And let's just check on the calculator what that mean monthly salary then becomes. Alrighty. So we have 84 plus 85 plus 87 plus 2 times 89 plus 83 plus 84 all over 7, right? And then we're getting the mean monthly salary is 85,857 rand. I'm not gonna put it to 2 decimal places. I think this is fine as it is. Or should let's be safe. Put it as it is. Okay. And now it says calculate the standard deviation in this interval. All right, I'm gonna have to use the statistics mode, ne? Shift mode. So let's go to stat. Or mode rather, not shift. So stat. And there's one variable. It's not bivariate. Okay, I need to put in the data, single variance. Where's the Casio calculator? I don't like this one. Okay, mode, stat. Yeah, I keep forgetting how to use this calculator. So let's just go back. Okay. Now let's say mode, stat, one variable, single variate. Yes, there we go. So now I can input the data. Go see what's happening with this calculator. So I have 84. No, this is not working out. It is not working out. Let's go again. Sorry guys, I should have practiced this before I came through. Plus this noise is not really helping. Okay, so what do we have? We have 84,000. Okay, let's just remove what we have there. We have 100. I don't know why it's not cleared. Clear all. Yay! 84,000. There we go. And then we have 85,000. We have another 84 actually. 1, 2, 3. And then there's an 83, I remember. Then now we can go to 85,000. I feel like I'm gonna re-record this because the noise is just too much. Yeah, and then there's 89,000. Okay, we're there, ne? Check the data. 89, 89. And then there's 87, 85, 83, 84, 84. Okay, great. Now shift. Remember how we do it? Shift, and then we go stat. How, Nkosian? What's happening now? Okay, so shift, stat. Okay. Yes, there we are. AC, shift, stat. Oh my goodness, what is happening? Okay, let me just go sort this out and then... Oh, there we are. So our mean is 85. So we are correct, right? There's 85. That's our mean. Everything is there summarized. Cool. And then the standard deviation. Standard deviation, let's just have a look over there. I hope you can see it, what it is. So standard deviation should be this. This, you see, it's 2,000. It is 2,294 and 62. Okay, so 2,294 and 62. No, the 5 there makes it 63. Okay. Now it says, determine the percentage of employees whose monthly salary lie in one standard deviation of the mean. So you know how to do this, right? One standard deviation, we're going to go ahead and we're going to say our mean plus the standard deviation. Okay, let me rather say mean plus standard deviation and then the mean minus. Okay, and then we have the mean minus the standard deviation. So our mean is 85,857,14. Okay, question 2. I will not have this background music. Excuse Mensa. Alright, 2,294,63. 2,294,63. So what is our answer? I'm just gonna go back to the normal mode because wow, this one is showing me flames. Okay, so we have 85,000 857,14 plus 2294,63. Okay, and we're getting there 151,77. And then on the other end, if we just go back and we subtract. Okay, subtract 2. Okay, and then we say equal to. So here we get 83,562,51. Right, did you answer the question? Oh no, ooh. We didn't. It says determine the percentage of employees. Not that we should determine what the standard one standard deviation is. So we need to determine the percentage of the employees whose monthly salary lie within one standard deviation. Okay, so let's have a look. Our upper bound is 83, our lower bound is 88, ne? So we are looking between 83 and 88. And looking at this, so this is, yeah, after 83 we have 84, 84, 85, 87. So we have 1, 2, 3, 4 out of 7. Okay, so 4 out of the 7 would be, we need to also multiply that by 100, ne? Okay, so 4 over 8 times 100, and that gives us, so 4 divided by 7 is equal to 0.57. If we multiply that by 100, and then that gives us 57%, or 57.14%. All right, and that was question 1. We took a bit long, but it is what it is. And question 2 will go way better without the background noise. Question 2. During a netball tournament, there are several stalls selling food and refreshments. In a period of 10 minutes at 6 stalls, the following was observed. All right, so we have the number of customers on the x-axis, the majority being 13 at stall number 6, and then the amount of money spent. Okay, and we can see at stall number 6 as well, the most money spent, 245. Okay, so this was plotted for us. Now let's see what the calculations require. 2.1 says, determine the equation of the least squares regression line of the data. All right, so that would be y is equal to a plus bx. Okay, so on your calculators, especially if you're using Casio, you're going to go to mode 3, which is that, and then you enter or click on the y is equal to a plus bx, which is the bivariate data. Okay, not 1 minus var, which is just the single variance. Okay, so there we have it. Let's just put in the information. So on the x, we have number of customers. So 10, 7, 9, 12, 8, and then we have 13. And then on the amount of money spent, we have 163. Okay, and then 138, 185, 220, 147, and 245. Okay, let's just see there. We have 13. Okay, so now what do? We can just say AC and then shift stat. All right, and we're gonna see the 2 variable calculate, but here we're looking for the regression calculate. Okay, and there we see we have y is equal to a plus bx. And what do we have in the place for a? So a, we have there 12,596. I'm gonna round off to 3 decimal places. So I'm just gonna say 12,596 and then plus bx. So we can see the gradient is positive. Our data there is plotting, it's an upward gradient. Okay, it's something like that. Yeah, so we are expecting a positive gradient b, which is 17,329 x. Okay, and that's 2.1. Then 2.2 says, predict the amount of money spent by 11 customers. Now remember, number of customers is x, right? So we're going to use our equation and we're going to say y is equal to 12,596 plus 17,329. I'm going to multiply that by 11. So you just can go back to the normal mode. Okay, 12,596 plus 17,329, and I'm going to multiply that by 11, and that gives us an answer of 203. So if you kept all those digits, you would get a better refined answer, but I'm going to round up to 2 decimal places here. So amount of money spent, I'm just going to put it in rands, 203 rand and 22 cents. Okay. And then later on, it says, the organizers of the event think that there is a very weak positive correlation between the number of customers and the amount of money received at stalls. Motivate whether you agree or not. What tells us if our correlation is weak or strong, whether it's positive or negative? It is the R value. Oh my gosh, I hope I can still go back to the stats mode. And yes, my data is still there. Okay, that's great. Now if I say shift stat and then I go to the 2 variable calculate. No, I should have gone to the regression calculate. Okay, shift stat and regression calculate. We need R. That's one thing that we didn't write down. Ooh, okay. Oh, actually, 2.3 I skipped to determine the correlation coefficient of the data. That's what I'm looking for. So this is 0.95. All right, great. I don't know how I skipped that. But 2.5, I couldn't have answered it without knowing the correlation coefficient. So here it cannot be very weak positive. Here it is very strong positive, okay? But I mean, it's 1 mark. So anyway, no. Motivate whether you agree or not. I do not agree, so no. And why is that? This is a very positive, a very strong positive. Okay, so this is a very strong positive correlation. Okay, this is literally very strong. So yeah, in any case, 2.5, it says at another stall, 6 customers spent a total amount of 195 Rand. Okay, so at another stall, let's just see here. So it's like maybe stall number 7, there are 6 customers and they have spent what? Let's just have a look again. 195. Okay, so if they have spent 195, we just need to check where will that plot. Let's just put away the calculator. So stall number 7, 6 customers, so there we are. 195, so 90, this is 200, so 195 is somewhere there. So now this pushes up. So currently, if we were to draw the line of best fit, let me just try there. It would work out to be maybe something like this. Nah. But with that point there, I mean, it's going to lift up this line of best fit. You know, something like that. If you want to start at that point specifically. But because we have some of the data, it wouldn't necessarily start there, but it lifts up. So there we have sort of like a steep gradient, and then here it's pretty much like less steep. But anyway, what are they asking? So we have put in that point. So if this point is included in the data, will the gradient of the least squares regression line increase or decrease? Remember, initially we had it like that. Something like this, which is quite steep, to something like that. Okay, so is the gradient increasing or decreasing? It is definitely decreasing because it is less steep. Okay, and then it says motivate your answer without any further calculations. Yeah, I mean, it will become less steep because this point is like an outlier. It's far away from the line that we have currently. So it's going to push it up so that it becomes less steep, okay? So you're going to find a nice way of saying all of that. But yeah, the answer definitely will be, it will decrease. Okay, it will be less steep. Okay, because yeah, we can say that point is sort of like above all the other points. It's like an outlier. It causes the data set to be, you can even put it in. Oh yeah, they said no calculations. But yeah, you can see that because it's above all the other points, away from the line, it does have an impact, causing it to be less steep. All right, it has decreased. And that is it for question 2. Question 3. In the diagram below, P, Q, and R are vertices of triangle PQR. Okay, so we can see that. Yes, there's R at the bottom. M is the midpoint of QR. So there we have it. And N is a point on PM in the second quadrant. There's N. The equation of QR is given by 2y minus 3x plus 9 is equal to 0. So I'm just going to put it there. That is the equation of this line. 2y minus 3x plus 9. There's no need to rewrite it, honestly. And the angle of inclination of QR is theta. Okay, remember, when they say angle of inclination, think to yourself, tan theta is equal to the gradient of QR. So yeah, gradient of QR. Okay. Anyway, 3.1 says, calculate the coordinates of M, the x-intercept of line PM. Okay, so M, we can see that it also lies on QR. So we can therefore get the equation of QR and then from there get the x-intercept. Okay, so QR's equation is 2y minus 3x plus 9. So I'm just going to write it in terms of y. So 2y is equal to positive 3x if we take the negative 3x to the other side, and negative 9. And then y is equal to 3 over 2x minus 9 over 2. And if we're looking for the x-intercept, we know that y is 0, okay, when we have our x-intercept. So, should have left the 9 on the other side. Okay, so we have 3 over 2x minus 9 over 2. If I take 9 over 2 to the other side, I'm just going to say actually 4.5. And 3 over 2 is 1.5x. So, x is then equal to, so 4.5 divided by 1.5. You can use a calculator, but I just know that it's 3 because, yeah, after having calculated this many times, x is equal to 3. So because we know that x is equal to 3, I can then conclude that M lies on the x-coordinate of 3 and the y-coordinate of 0. Okay, and that's 2 marks. Then they say determine the equation of PM in the form of y is equal to mx plus c. So PM, okay, now we're looking for this equation. All right, so we have P, and now we just worked out what M is. So we have P minus 9, 12. Okay, let's just write it there. And then M, which is what we just calculated, which is important to make sure that your calculations are correct, or else you are forwarding the incorrect stuff if it's incorrect. So what we're going to do, I'm just going to say the equation. If you have two coordinates and you don't have the gradient, you can just say y minus yp over x minus xp is equal to ym minus yp. Okay, just make sure if you're subtracting yp, stick. If you're subtracting the point p, then stick to it, okay? Xm minus xp. So now yp is 12 and xp is minus 9. So minus 9, that's just going to be positive 9. And then ym is 0 minus yp. Xm is 3 minus xp minus minus is going to be a plus. All right, so basically we have, I'm thinking, wait, should I write this? So we have y minus 12, x plus 9. So we have minus 12 over 12, which is just negative 1, okay? I'm just going to forward it that side. So we have y minus 12 is equal to this negative 1, but I'm going to take the x plus 9 to the other side, and this negative 1. All right, and are we expecting a positive or negative gradient? We'll see again. So we're going to have negative x minus 9 plus 12, and finally y is minus x plus 3. Does that make sense? Are we okay with this answer? PM has a negative gradient, so yes, x should be negative, or the gradient rather should be negative, And because we have our x-intercept at 3, yeah, we have our x-intercept at 3. We just don't know what the y-intercept is, but we worked it out as well to be 3. Ne? Okay, so our equation there is y is equal to negative x plus 3. All right, cool. Now it says calculate the size of theta. Remember, theta is from line QR. Okay, do we have the gradient of QR? Yes, we do, because they gave us the equation, and the equation, remember, we actually rewrote it in terms of y. So it is 3 over 2. The gradient is 3 over 2. So that is what we're going to use, right? Using this equation over here. So tan theta is equal to the gradient of QR. Tan theta is equal to the gradient of QR. And that gradient, okay, if you take it, it's going to say arctan. Gradient of QR, we said it is 3 over 2. Ne? 1.5. And then we're just going to determine what that is. So if we say shift 10 and 3 over 2, which is just 1.5, I want to put in there 3 over 2. So yeah, wait, is this, oh, guys, you see this calculator is in radians. Make sure you are in degrees, because I was like, no way is this answer. You can't get an angle of 1 degree. If we ever look at our sketch over there, it doesn't make sense. We need probably something bigger than 30 degrees. Okay, so if you get like a 1 degree, then you must just check, are you using radians or degrees? So make sure your calculator is on degree mode. Okay, and then we get back. Now we can see. Actually, the arctan of 1,5 or 1.5 or 3 over 2, it is 56 over 31 degrees. Okay, 2 marks. Don't lose it. And then 3.4, it says show that B is 3 minus A if P, N, and M are collinear. Collinear lines, we've discussed it before in one of our videos. It means P, N, and M are actually in a straight line. Okay, let's go have a look. P, N, and M, yes, we can see. We can see that they're in a straight line. Okay, and we have P, the coordinate. We have the y-intercept there. We also have M, which is 3, 0. Now, what are they saying? We need to show... Ooh, the scrolling up and down. We need to show that B is 3 minus A. Okay, let's go up again. Okay, so B is 3 minus A. All right, how are we going to do this? We know that our equation for PM, because we have QR, our PM equation, we already determined that it is y is equal to negative x plus 3. So let's just see. Y is equal to negative x plus 3. So what I'm thinking is, how about we substitute A, B into this equation. Let's substitute the point N into this equation and let's see what it gives us. Okay. Substitute the point N because we have y is equal to negative x plus 3. And our point there, N, remember we said N is A, B. So in the place of y, we put B. In the place of x, we put A. And if we write, oh, there it is. Okay, yeah, it's 1 mark. So 3 minus A. There we have it. Let's make our A look like an A instead of a 9. No. 3.5. Hence, determine the value of A and B if NQ is 5 root 5 units. Okay, let's go see where NQ is. Alrighty, so here we are. So this is N and that's Q. Okay, and that is 5 root 5. Okay, and now we need to determine what A and B is. So here, we have A, which is A, and B, which we just determined in the previous question. Now we can use the distance formula in order to get what the values of A and B are. All right, so let's then go ahead. Righty. Okay, so like we said from the previous question, that B is 3 minus A. Okay, so we have the coordinate. Let me use a different pen color. So we have A, and B is 3 minus A. Okay, and we also have, okay, and we also have, now I forgot which one is A and which one is Q. Yeah, this thing of having to scroll up. So Q is 9, 9. Okay. So Q, and then the distance of NQ is 5 root 5. Okay, so let's use the distance formula and get our story straight. So the distance of NQ is 5 root 5. And then we have the x coordinate of Q, which is 9, minus the x coordinate of N, which is A, and that is squared, plus the y coordinate of Q is 9, minus the y coordinate of N, which is 3 minus A, and that is squared. So I'm just also going to square this side because that square root, putting it in, we don't really have enough space. Yeah, so then 5 squared, that is 25, root 5, that's 5. So 25 times 5, that will be your 125. And then 9 minus A squared, so we have 81 minus 18A plus A squared. And then we have plus 9 minus 3 is 6, minus minus, we have plus A, and that is squared. I'm just going to take 125 to the other side. So we have A squared minus 18A plus 81, and then plus 36 plus 12A plus A squared minus 125. All right, so we have A squared plus A squared, that's 2A squared, minus 18A plus 12A, that is minus 6A, and then 81 plus 36 minus 125. Okay, 81 plus 36 minus 125. Home. Okay, 81 plus 36 minus 125. Okay, that's negative 8. All right, and I'm going to just divide by 2 throughout. So I have A squared minus, yes, 3A. Yes, 3A minus 4. Okay, just making sure that I wrote everything correctly. And then when I factorize, 4 and 1 gives me 3, right? So those are the factors of 4 that I'll consider. 2 and 2 will not work, but I need minus 4 plus 1 in order to get 3. So there we go. So then ultimately A is equal to 4, or A is equal to negative 1. But now in terms of N, we need to look at which quadrant N is in. Is it positive? Is it negative? What are we expecting? So between 4 and negative 1, N is on the negative side of the x-axis. So we are expecting N, or rather A, to be negative 1. Okay, and remember we said B is 3 minus A, right? So if A is negative 1, then 3 minus 1, that's going to be 4. So there we have our coordinates for B. but let's go write them down where the space has been provided. So we're not going to consider a is equal to 4. We know that a is equal to negative 1. And because b is 3 minus a is negative 1, so b is 4. Therefore, n is minus 1 and 4. They didn't really ask for the coordinates of n, they just asked for the value of a and b. Alright, and then 3.6 is determine the equation of a circle having center at O, the origin, and passing through point R. So we have the origin here, O, and now we need to know what R is. Alright, because if it passes through R and it has the center O, it means that our radius will be the distance between O and R. Okay, so our radius squared will be the x-coordinate of R minus, the origin squared, plus the y-coordinate of R minus 0 squared. Okay, so we're basically looking for the radius squared. I'm going to keep it at radius squared because ultimately then when we have the equation of the circle, we will say x squared plus y squared is equal to r squared. So they've simplified matters for us by having the circle at the center, at the origin, having the center at the origin. So let's go look at where r is so that we see what answer we might be expecting. Okay, so here's r, and yeah, so basically, yeah. Oh, I had put this in. Okay, so this is basically r there. So OR, but now we need to get the coordinates of r, and by doing that we know, remember initially they told us that the center of QR is M. Okay, we already have M, we have Q, we can definitely get R. So let's try to work that out. Okay, so we know that our midpoint is M, which is 3, 0, and we need the x-coordinate of R plus that of Q, which is 9, and we're dividing that by 2. Then the y-coordinate of R plus that, the y-coordinate of Q, which is 9, and we're going to divide that by 2. Okay, so yeah, we then can say xr plus 9 is equal to 2 times 3. Okay, or rather let me just do it the long way so that you can see where I'm getting things. So we're going to make that equal to 3. Okay, therefore xr plus 9 is equal to 3 times 2. Therefore xr is 3 times 2 minus 9. Okay, the coordinate of r, the x-coordinate of r is going to be 6 minus 9, which is minus 3. Alright, and then with y as well, so we have yr plus 9 over 2 is equal to 0. So 2 times 0, that's just 0. And 0 minus 9 is just minus 9. Okay, therefore I can then say r is minus 3 minus 9. Okay, and then we can then get the distance, which is our radius. So I'm just going to remove this. Okay, and then say, therefore, the radius squared is equal to the x-coordinate of r minus 0, right? Let me just put there, we have negative 3, negative 9. Okay, so basically we're going to have minus 3 minus 0, and we're going to square it. And then we have minus 9 minus 0, and we're going to square that. So r squared is basically minus 3 squared, that's 9. Minus 9 squared, that's 81. So r squared is 90. Therefore, the equation of our circle, x squared plus y squared is equal to r squared. X squared plus y squared is 90. All right, and we are done with that portion. So now we can move over to 3.7. So it says the acute angle between the lines QR and the line with equation y is equal to mx plus 4 is 45 degrees. Oh, okay. Determine the possible values of m. All right, so the acute angle between lines QR and the line with equation y is equal to mx plus 4. So the y-intercept is 4. We don't know what the gradient is, okay? So, okay, I see here we have the sketch. Oh, at least we don't have to go and browse all the way up. So let's say I know here we had, let's just fill in what we have. We had this coordinate over there. M is 3 and 0. And we have r as minus 3 and minus 9. Okay, and then 4, it's probably going to be somewhere. Well, I don't know. I don't know where it is. Okay, I don't want to assume. Let's just see. With n, we know that it is minus 1 and 4. I really don't know the equation of nq, and I don't know what the y-intercept will be. So let me not make guesses here. But let's just say, for argument's sake, maybe that's 4. Right? And then we have a line. Let's just go back again. QR and that line. So QR is there. Okay, let me just highlight that. So we have QR. And we have a line passing through the y-intercept at 4. So if this thing can either have a positive gradient or a negative gradient. So if it has a positive gradient, it might look something like this. Let's see. Okay. Oh, what do we know? Yeah, it has that positive gradient, and this is 45 degrees. All right. And since it has that positive gradient, what else am I missing? Yeah, let's see how we would work it out. We're looking for m, right? We're looking for the gradient of this line. So how are we going to get the gradient of this line? Let's say here I have the angle of inclination, it's alpha, it's theta, and we have alpha over here. So theta, you know, the external angle of a triangle is equal to the sum of the interior opposite angles. So I have theta would be equal to alpha plus 45. We already worked out what theta is. I think it was 50 something. Yeah, we can go check that out. I just want to see what we're working with here. So we can get theta is equal to alpha minus or plus 45, né? And then we can then work out what alpha is. Alpha will be theta minus 45 degrees. I should be writing all these things down somewhere. Okay, let's go write it down there. So basically we're saying that alpha, okay, let's start from the beginning. So the angle of inclination for the line, we need to guide our markers, né? So angle of inclination for line y is equal to mx plus 4. That would be alpha. Okay, and then we're going to say theta is equal to alpha plus 45. All right, so then ultimately alpha is theta minus 45 degrees. And now how are we going to get alpha ultimately? So we're going to say 10. Okay, we're going to say 10 alpha would be equal to this m that we're looking for. All right, so that's one portion. That's if we have a positive gradient. Okay, so I'm just going to say this is for the positive gradient. What about the negative gradients? Okay, we need to get the answer there. And we need to also get the answer there. So what is M ultimately? Okay, what if we then had a negative gradient? How would that one look? Let's also get a different shade color. Maybe let's go with purple. If it was a negative gradient and we needed to get 45 degrees, let's see. So it has to pass through 4. Let's just say, okay, that looks, that doesn't look like 45 degrees. It's quite close to, well, not even 90. 90 would be somewhere, yeah, but it's not 45 degrees. So let's just keep rotating it. So maybe if it was somewhere here, I think we're almost there. Yeah, I think this would be 45 degrees. Okay, so let us just remove the previous line. So maybe let's make it as we rotate it. So let's say that's 45. Okay, that's when we have a negative gradient. And if that's the case, now let's see our triangle. So we have 45 over there. Okay, let me make this a little bit smaller. So this is our 45 degrees, no? So now we have, I'm looking at this little triangle over here. How can I relate it? Okay, I can say, okay, if I have this little triangle over there, this is 45. This is opposite angles, vertically opposite angles, so that's theta. And now how am I going to get this angle over there? Well, I know that I can also use angle of inclination over here. So this is now where, this is our alpha if we have a negative gradient. So if this is our alpha, I can then say, actually the same thing. I can say external angle in a triangle is equal to the internal opposite. So yeah, it's the same. It really is the same. Yeah, I hope I'm not making errors here, but yeah, this looks like it is the same thing. But if you wanted to do it the long way, you could have said alpha plus this dot is equal to 180, and then you get what that dot is, and then ultimately, yeah, you can sort it out. But I see here we also have alpha can be equal to theta plus 45 degrees. Okay, no, sorry, theta. No, yes, alpha. Ooh. I'm confusing myself here. Alpha is equal to theta plus 45 degrees. Yes. Alpha, oh, let me change the pen. Alpha is equal to theta plus 45 degrees. Yeah, let me not confuse myself. All right. Let's put it there as well. Okay, so I think then we can work it out. Same thing as well. Now let's go back. Let's remember or remind ourselves, what did we get for theta? That will make life a little bit easy for us. We got 56,31. So let's write it down, 56,31. 56,31 minus 45 is equal to, and then yeah, let's get that answer. 56,31 minus 45 is equal to 11,31 degrees. No? Ooh, no. And then when you look at the other side, this is now 56,31 plus 45. Let me just shift this a bit to the bottom, give us a bit of space. Yeah. Okay, so let's see. if we have a plus 45, it's 101,31 degrees. All right, and then we're looking for tan alpha. So if we say tan of 56,31, it's already rounded off, so it shouldn't matter. But yes, after that, I get that the gradient is 0,2. That's one possibility if you have a positive gradient. And then what would it be? So M gradient is tan 101,31. And what is that answer? So we have 10 plus, so we actually have, it's pretty much -5. And we are expecting a negative because that's the option where your gradient is negative. So yeah, if it says find the values or determine the possible values of M, it could either be 0,2, quite flat, all right? And then we have quite a steep, and you can see this is very steep, right? So it makes sense that it is -5, whereas this one is relatively flat. That's why you get a gradient of 0,2. And that rounds it up for question 3. Question 4. In the diagram, the equation of the circle centered at B is given by x plus 1 squared plus y minus 1 squared, which is equal to 20. Okay, that's nice. So you know your center already. You can just note it down. So your center is -1 for x and +1 for y. And you know the distance for AB is actually root 20. Okay, that's the radius over there. Radius squared. What else do we know? We know we have a line tangent to the circle. So I know that the radius and a tangent. Okay, let's read. DF is a tangent to the circle at A. It would be incorrect for me to assume that it's a tangent because it looks like it, so I need to read it. So DF is a tangent to the circle at A with D and F. Okay, so because of that, I can then say a tangent line and a radius, they meet up at, they're perpendicular to each other, basically 90 degrees. The x and y intercepts respectively. Okay, yeah, D and F are the x and y intercepts. C, where is C? Oh, there they gave us, it's -1. And 6 is a point on DF, right? With BC parallel to the y-axis. We can already see they have the same x coordinate, right? And we can note then that the distance between C and B is 5. All right, and then CBA, so angle B in CBA is equal to ADO. Okay, so theta here, and we also have theta there, they're equal. Okay, interesting. Now, what is the first question? Write down the coordinates of B. Oh, okay. We already did, so it's -1 and 1. Okay, that's B. And then show that AC is √5. So we can use Pythagoras over here. Remember, it's also 90 degrees here. So if I were to draw this triangle facing the right way up, I know that at 90 degrees I have A, and then I have C, and then I have B. And I know that BC is 5, right? And then I know that AB is √20. So I can use Pythagoras to get AC. So I can say AC is equal to, AC squared is equal to BC squared minus AB squared. Okay, Pythagoras. And then BC, we know that it's 5, but I think let's just show how we got it. So we said 6 minus 1 squared minus AB, and we know AB is √20. They gave it, well, they didn't really give it to us as √20, but they gave us the radius, so we know that AB is √20. and that can be squared. So we have 6 minus, you know what, let's just put all of this in the calculator. But 6 minus 1 squared, that's going to be 25, and 25 minus 20, okay, we don't need the calculator. We have 25 over here minus 20, so that is 5, right? AC squared, so therefore AC will be root 5. Okay, didn't really need the calculator, and we've shown it. So that's 3 marks. Then it says write down the value of tan theta. Okay, again looking at our triangle, where is theta? Theta is there by B. Okay, so tan theta, tan, remember tan is opposites. This is our opposite, so it's AC, opposite over adjacent. Okay, so basically tan theta is AC over AB. AC over AB. So tan theta, maybe that's why we had to show that AC is that. Okay, we said it's AC over, speaking now, I forgot, over AB. Yeah, AC over AB, and we've just determined AC is root 5. We know AB, it's root 20. Let us deploy our calculator, and we put there root 5 over root 20, and that is 0,5. All right. Let's put it in. Oh, I was wondering, would it be the same if I said 5 over 20? For some of you who are wondering, yes, it would be the same. Okay, yeah, this is the same as just saying big root and then 5 over 20. 1 over 4. But yeah, anyway, oh, 1 mark. Anyway, 4.4 says, show that the equation of AB is given by y is equal to negative 2x minus 1. Okay, let's just go back to AB. So we have A. No, we don't. We don't have the coordinates of A. But we have the coordinates of B. What else do we have that we can use in order to get the coordinates of A and possibly get the equation? I have... Okay, can I have the line of FD? Do we have an equation somewhere? No, because I know that FD is parallel to AB. So if I were to start by getting the gradient, I would know the gradient of FD multiplied with the gradient of AB. That would give me negative 1, right? So yeah, let's just see how we can work this out. So using our angle of inclination, right, we can say tan theta is equal to our gradient, right? And we just worked out what theta is. Or we can work it out if we haven't worked it out already, but we did. Or am I imagining things? Or we worked out tan theta, we just didn't work out theta. Okay, so no, we did. If we're saying the gradient is tan theta, we know that tan theta is 0,5. I don't need to work out what theta is. So I have the gradient. Okay, cool. But what gradient is that for? Okay, so yes, I can use it for here. Okay, I don't have to work out theta. I just know that this gradient is equal to tan theta, which is 0,5. So we have the gradient for DC or DF. Now I can get the gradient of AB. So this is the gradient of, I'm just going to say DF or DC, doesn't matter. The points are collinear. So now, therefore, in order for me to get the gradient of AB, I'm going to get negative 2, right? Because the gradient of DF multiplied the gradient of AB has to be equal to negative 1. So negative 1 divided by 0,5 is going to be negative 2. Okay, so I have the gradient of AB, which is -2, and I just need a point, right? And remember, we have the coordinates of B, which is -1 and 1. So we have a gradient, we have a point, we can definitely get the equation of the line using y is equal to mx plus c. So if I plug in the gradient, it's going to be -2. I plug in the coordinates, I have 1 here, and I have -1 plus c. So c would be equal to 1, and -2 multiplied by -1 is +2, so 1 minus 2. So then c is -1. Therefore, the equation is y is equal to -2x minus 1. So we have shown that. And now 4.4, determine the coordinates of A. All right, let's go back to our sketch there, plot, or rather just put what we know. So we know that the equation of AB is basically y is equal to -2x minus 1. How do I get the coordinates of A? So I have this line. What you can do, you can try to get the equation of this line, right? You have a point, you have a gradient, and you can take the equation of AB, of the line AB, and then solve it simultaneously to get what the possibilities are of, of A, okay? We can do that. Or what can we do? We can say, yeah, what can we say? So we have the equation of the circle. Yeah, there are many ways to skin a cat. I think I'm going to go with getting the equation. I mean, I already have a point. I already have a gradient. I'll think of another way now. I'm just fixed on this solution in my mind. So if I were to get the line for DF, is equal to mx plus c, and I know that the gradient is a half, and I know that the point f, or was it f that we given, was it c? I think it was c, -1 and 6, ne? We can just confirm that, but yeah, I think it was c, -1 and 6. We can then substitute it in, so we have 6 there, we have a half, and then our x is -1, and then c would be 6 plus a half. Okay, so it's 6.5. And therefore the equation is y is equal to a half x plus 6.5. All right, now we have two equations there. Okay, so we have a half x plus 6.5, which is equal to the other equation, -2x minus 1. The intersection of the two equations, -2x minus 1. So if I take -2x to the other side, it will be +2x. So I will have 2.5x. And if I take 6.5 to the other side, it will be negative. So -1 minus 6.5 is -7.5. And then 7.5 divided by 2.5, 3, ne? Yeah. So there we go. But wait a minute. It should be negative because A is on the negative side. Okay? Because if you get something else, then yeah, then something is wrong. So you can see A is on the negative side. We get -3. What is the y coordinate? I can just substitute that in any of the equations. The simplest one, it doesn't really matter at this point. But we can say y then is equal to a half x plus 6.5. So we have 0.5 times -3 plus 6.5. So that is 5. Y is 5. All right. Therefore, A is -3. and 5, and thus that makes sense. If you go and you look, yeah, I mean C is at y value of 6, so A has to be below that, so it does make sense. Okay, so there we have it. We have the equation, or that we have determined the coordinates of A. Oh, because A actually touches the circle, what you could have done is taken the equation of the circle, and then you substitute in the place of y. Remember we said y is equal to blah blah blah, and we have the equation of AB, which we determined previously, so you can just go substitute that equation in the place of y, write y in terms of x, and then solve for x. Then that should also work. All right, now 4.6. So it says calculate the ratio of the area of triangle ABC to the area of triangle ODF and simplify your answer, and then we'll be done with question 4. So yeah, the scrolling up and down is taking time. Okay, so it's in triangle ABC. We're going to need a different colored pen. Okay, triangle ABC. At least it's a right angle triangle. Let me just put it here. It'll be easy to calculate the area then, unlike having to use like the area rule or... Okay, I actually had that sketch. I don't know why I'm writing it out again. Let me just remove that. So we have the triangle. It's there on the side. AC, we determined it was root 5. Okay, we had to prove that at some point. So basically, yeah, we can calculate the area of triangle ABC. What other area are we looking at? They talked about, let me just calculate the area of triangle ABC. Okay, so area of triangle ABC, if we just sketch it out for ourselves again. Okay, it'll be half the breadth times the height. And if I remember correctly, B was up there, and then A was at the 90 degrees, and then we have C. Okay, and then AB, we had it as root 20, no? We'll just go and check ourselves. And AC, we worked it out, it's root 5, and BC was 5. So if we work out the area there, we have half root 5 times root 20, and that becomes 50. No, yes. No. What do I say? Root 100 is 10. 10 times a half is 5. So yes, 5 units squared. All right, and now we need to go to see triangle ODF. Okay, triangle ODF. Let's just see if we can sketch it. Here's O, and there's D. Oh, it's that big one. Okay, at least we also have a right angle triangle. O, there's 90 degrees. D, we have theta. We never really worked it out, but we can. And then we have F. What else do I know? We had this equation for line DF, right? So I can definitely get F, I think, is 6.5, the Y value. So I have 0. Remember, we worked out the equation. Let's just check again. But the equation, we had 6.5. If I'm not mistaken, yes, Y is equal, yes, 6.5. So yeah, we have the Y coordinate of, actually we have the coordinates of F, and we have the coordinates there, it's at the center. So we have this distance over here, it's 6.5, And OD, we don't need it. As long as we have theta, then we can work out what OD is. And what will we need? We could say tan theta is equal to OF over OD. Okay, so let's just go and work out. Yeah, let's go work that out. Let me just copy all of this instead of wasting time. Okay. Okay, I can paste it over there. Because it's not really bad. It's not really that bad. Ooh, can I paste? Okay. That I was gonna paste something huge, but it's fine. So there we have it. So getting back to theta. Remember we said tan theta is a half in the previous questions. Yes. For DF. So yeah. Tan theta is a half. So therefore, theta is equal to, so we're going to say shift tan 0,5. That's 26,57. So 26,57 degrees. Now we can say, oh gosh, I didn't really need to work this out either. So we have tan theta, which is a half, is equal to OF, 6.5, over OD. Okay, so OD is equal to 6.5 divided by a half. Okay, and that is 13. So OD is 13 units. Now I can get the area. So area of triangle ODF is equal to half 13 times 6,5, and that will give us 0,5 times 13 times 6,5, 42,25. Okay, yeah, I'm just gonna say 42,25. Now they wanted a ratio. So they said calculate the ratio of the area of ABC to the area of ODF. Okay, so triangle ABC to triangle ODF. All right, and then what do we have there? We have ABC as 5. Oh, let me put in the units squared. All right. Okay. Yeah. Geez, I'm looking at my thing again. Let me just check something. Okay. So we have 5 is to 42,25. And what do we have then? Yeah, I think so 5. If we're gonna put 1 is 2. Let me see how I can put it. So it's basically 20 is to 169. Remember 42,25 is like 169 divided by 4. And if I take that 4 to the other side, I have basically 20 is to 169. So yeah, it's just to avoid having the decimals. Okay, I hope it makes sense. But yeah, there we are. So that is the ratio. 20 is to 169.05 is to 42,5. Or you can say 1 is to 42,25 divided by 5. But I think this should be fine. And that's it for question 4. Question 5. All right. Trigonometry. So it says simplify that to a single trigonometric term. All right, so sine squared 180 plus x, let's start there. 180 plus x is in the third quadrant. Only 10 is positive. So we have a negative sine x. But remember this squared that we deal with later. Okay, so please don't write this because that would be incorrect. Okay. And then we have sine of a negative angle. The sine of a negative angle is actually negative, so we have negative sine x. And that's all over. So sine 90 plus x. 90 plus x is in the second quadrant. Sine is positive, right? So, but remember there's this negative that we have, so we need to put it there. And then the sine and the 90 actually turn into a cos. So I have negative cos x. And then tan x can simply be sine x over cos x. And we have that negative 1. I don't know if I should change it to sine squared x plus cos squared x yet, but let's just leave it because we don't know. Then negative sine x squared is actually sine squared x multiplied by negative sine x all over negative cos x times sine x over cos x. So the cos's cancel, this sine and that sine cancel, the negatives cancel, we are left with, oh, there's that negative 1. We are left with sine squared x minus 1. I'm going to change that to sine squared x plus cos squared x. If I remove the brackets, the signs are going to cancel and I'll be left with negative cos squared x. Okay, so we've reduced it to a single trigonometric term. Now, given cos a minus b is equal to that identity. Okay, now it says use the above identity to deduce that sine a plus b is equal to sine a cos b plus cos a sine b. I've done a video, if you look at our maths playlist, the last video is all the examinable proofs. All right, all of them for paper 1 and paper 2. So this is one of them. So what we're using, or what we're doing here, we're using cos a minus b to eventually get here. All right, and we've been given sine a plus b. So how do we maneuver around that? How can we go from cos a minus b to sine a plus b and eventually to get to sine a cos b plus cos a times sine b? Okay, so I'm going to take this cos, right? And I know that eventually this cos has to turn into a sine, or rather, if I want to change this sine to this cos a minus b, I need to change it using the co-ratio function, if I could say, for lack of a better term. So I know that if I take cos and I have 90 degrees minus this a plus b, this is actually cos and 90 will turn into a sine, right? And the angle that we have there is here. Okay, so that is why the sine a plus b is actually equivalent to cos 90 minus a plus b. Okay, so those are equivalent. And then now I can simplify, remove the brackets within the brackets. So I have 90 degrees minus a minus b. All right, now I need to think again. So if I were to take the 90 minus a and group it together and leave out the minus b, how would that affect things? So I have 90 minus a as one angle and I am subtracting b. Okay, then I'm going to try to expand that using our identity over here. All right, cos, remember with the cos identity, so I'll have cos 90 minus a times cos b. Okay, Cos, cos, sine, sine. And because I have a negative here, I'm going to have a positive in my answer. So I have sine 90 minus A times sine B. All right. And if I simplify that, remember, 90 minus A is in the first quadrant and cos is positive in the first quadrant. And cos and 90 turn into a sine. So we already have that sine A. And we have cos B. And then we have this plus 90 minus A, first quadrant. Okay. And sine is positive there, so we have positive cos X. Remove that positive. And sine B. Okay. Sure. I'm cooking and I'm hearing something is burning. Let me come back. Alright, so without using a calculator, simplify the following. Cos 420, cos 15, sine 300, cos 105. So this is, okay, cos, sine, cos. I'm going to go and look where is 420 first and foremost, and then try to see if I can simplify. Okay, so this is 0, it's 9, 18, 27, 36, 40, yeah, 36 plus 90, 45. So 42 somewhere here, no? So what is, yeah, 9, 18, 27, 36, 45. Okay, so 420 is in the first quadrant. So what is 420 minus 360? It's 60. Okay, so I actually have cos 60. Yeah, I almost said, let's get the calculator. Okay, and then cos 15, I'm going to leave it like that. Let's just reduce everything to its acute angles, and then we'll see what's happening. And then sine 300 is in this quadrant, okay, the fourth quadrant. So it would be sine 360 minus 60. Okay, and cos 105. So 105 is in the second quadrant. Okay, so before I even reduce it, I know sine in the fourth quadrant is negative and cos in the second quadrant is also negative. But let's just do this rather. So 180, I would have to subtract 75 in order to get 105. 75, okay, that 75 is not clear. All right, let's go ahead again. So I have cos 60, cos 15. I have negative, okay, this is plus, negative sine 60, and negative cos 75. All right. Okay, simplify further. I will leave this cos 60, cos 15. Negative and negative is positive, so I have positive sine 60. I can see I have cos, so I'm expecting a sine. Okay, but this 75, if I can change it, I can change it to, remember, co-ratio sine and cos. Okay, co-ratios meaning the angles can add up to 90. So 90 minus 75, that will be 15. Okay, if you check on a calculator, cos 75 is the same as sine 15. All right. So yes, so now that I have that, cos, I have a positive here. So it means I have cos something. If I have a positive here, it means I'm going to have a negative something. So I can see it's 60 minus 15. And 60 minus 15 is 45. And cos 45, oh my god, they expect you to know this is actually 1 over root 2. Or you can write it as root 2 over 2 if you don't want your denominator to be a third. Okay, so that's 5.2.2. And now it says, given that tan squared x times 1 over tan squared x minus 1, prove that tan squared x is equal to cos 2x over cos squared x. Okay, so what are we going to try to prove? Are we going to prove the left-hand side is equal to the right-hand side, or prove that the right-hand side is equal to the left-hand side? I think it's better taking the tan over to the cos, unlike starting with the cos and trying to work yourself to tan. Okay, so let's rather work with the left-hand side. Now, if I multiply in the first side, on the first side, so the tan squared x will basically divide with the tan squared x, so I'll be left with 1, and then we have negative tan squared x, and at this point I am going to write the identity for tan, which is sine over cos, so sine squared x over cos squared x. How can I get to cos 2x? Because this is my goal here. I already have cos squared x. So how can I get to cos 2x? I'm going to have here a common denominator, which is cos squared x. And here I will have cos squared x minus sine squared x. Oh, okay, that's not bad. So yeah, cos squared x minus sine squared x is actually cos 2x. You can actually have a look at it in your formula sheet. So we have cos squared x, so that's equal then to the right hand side. Okay, that wasn't so bad. Now it says find, for what values of x in that interval is tan squared x undefined. Okay, so if it's going to be undefined, you're going to look at the denominator. Okay, but in this case, because we have proved that this is equal to the right hand side, you can look at the denominator, which is cos squared x, and it's only 1 mark, by the way, but anyway. So you're going to say cos squared x being equal to 0, because that is where it will be undefined. Okay, so if you were to solve for it, if you're going to draw the function, that's why it's 1 mark, they expect you to know this. If you're going to draw the cos function, quick, it starts off here, and then it does that. Okay, so where is it 0? It's 0 at 90 degrees. That's 180, that's 270, that's 360. Okay, so it's actually where x, because now they said between 0 and 180, so I can't even go to 270 there. So x will have to be 90 degrees. And then 5.4, determine the general solution of the equation cos 2x is equal to cos x. Okay, so in this case, I'm going to leave cos x as it is and then expand on cos 2x. Okay. Yeah. Because yes, I do have cos and I have cos. If I say 2x is equal to x, do you realize that I actually don't have a solution? Because the x's will cancel out. So that cannot be the solution, really. So I'm going to have to expand cos 2x. And cos 2x, this double angle, has 3 options. But because I have a cos x here, I will start off by using the identity where it only involves cos, okay? And that would be 2 cos squared x minus 1 is equal to cos x. And I'm going to take the cos x to the other side. So I have 2 cos squared x minus cos x minus 1. If it's difficult for you to look at it this way, you can say you have 2y squared minus y minus 1. And then you can factorize. Okay, make that equal to 0. You can factorize, so you'll have 2y and y, and then you have 1 and 1. And then you're going to say that's going to be minus 1, that's going to be plus 1. Okay, because negative 2y plus y is going to be negative y. But, yeah, remember here we said let cos x equal to y. So bringing it back, we can actually, this is, yeah, we can say 2 cos x plus 1 and cos x minus 1 is equal to 0. Okay, then we can solve for cos x. No? Oh, you're gonna have, yeah, quite a solution here. Okay, do we have enough space to write on? I hope so. Alright, so let's start with 2 cos x plus 1 is 0 and solve it. So we'd have that cos is negative a half x. And what would be the reference angle? If we have negative a half x, so shift cos negative a half. Okay, it depends. So there are 2 ways of doing this question. You can either take the negative angle as it is and tell yourself where is cos positive, which is the first and the fourth quadrant. Or you could look for cos a half. Okay, let's say you got cos half. All right. And we know that the reference angle is 60 degrees, but where is cos negative? It's negative in the second and the third quadrant. I think let's take that approach. Okay, then we have cos x is equal to, cos x minus 1 is equal to 0, so cos x is equal to 1. And as a result, our reference angle, I think it should be 0. So is cos 1, that's 0. Did they give us an interval? No, it's just a general solution. Okay, so 0 degrees, we'll work with that, right? And we know that cos is positive. On the, just do this. Cos is positive on the first and the fourth quadrant. Alrighty, so now let's get to working. I don't know how everything is going to fit in, but for the second quadrant, let me rather do this. For quadrant 2, we know that x is equal to 180 minus the reference angle plus 360 times k, where k is an element of integers, right? And so it's going to be 120 degrees plus 360 times k. And then for quadrant 3, x will be 180 plus 60, which will be 240, okay, plus k times 360 or 360k, where k is an element of integers. And then on with regard to quadrant number 1, we can then say x is equal to 0 degrees. Yeah, so how do you put it? X is just equal to 360 times k, where k is an element of integers. And for the fourth quadrant, we can say x is equal to 360 minus 0, which is simply going to be 360 degrees plus 360 times k, where k is an element of integers. So yeah, I hope that was clear, that it makes sense. And we have the 240, we have the 120, we have the 360k and 360 plus 360k. Okay, cool. So that's 5.4 and 5.5. So it says, given that sine theta is equal to a half, calculate the numerical value of sine 3 theta without using a calculator. Okay, so here you're going to use your compound formulae. All right, so sine theta is a half, so you need to now get to a point where we can break up the sine 3 theta. And I'm glad they said 3 theta, because if they said 4, there are many options available. Okay, so 3, I can break it up into 1 plus 2. All right, and then from there, we're going to use the compound formula. So we have sine cos plus cos sine. All right, so sine theta is fine. We have that value as a half cos 2 theta. I want to write it in terms of sine, okay? So with the identity that we have, we can say 1 minus 2 sine squared theta. All right, and then I have cos theta here. All right, and then sine 2 theta, it's going to be 2 sine theta cos theta. Okay, so let's just see. If I multiply inside, I'm going to have sine theta minus 2 times sine cubed theta plus 2 sine cos squared theta. Okay, remember I don't really want cos anyway. So what I'm going to do, I have, okay, minus 2 sine cubed theta plus 2 sine theta, and then the cos squared. Remember, sine squared plus cos squared is equal to 1, so I'm just going to say cos squared is 1 minus sine squared theta. Ooh, okay. There we go. And if I multiply that in, I have 2 sine theta minus 2 sine cubed theta. Can I simplify this? Yes, I can simplify it. So sine theta plus 1, sine theta plus 2, that will be 3 sine theta, and then minus 2, that's going to be minus 4 sine theta. I'm just going to take the cubed out so that I can substitute in nicely. So now if I put in half in the place of sine theta, I'm going to say 3 times a half, and then minus 4 times a half cubed. So that will be 3 over 2 minus 4 times 1 over 8, because 2 cubed is 8. So basically I have 3 over 2 minus a half, and that's simply 1, right? 3 minus 1 is 2, 2 over 2 is 1. Okay, and are we done with question 5? Oh, thank goodness, done. Question 6. In the diagram below, the graph of f of x is equal to 2 cos x is drawn for that interval of negative 180 to 180 degrees. Né? And then it says, on the grid below, draw the graph of g of x minus cos 2x. So here I'm going to suggest that you go to the table, put in the formula so that you can finish quickly. So we have negative cos 2x. How will that affect the graph? Firstly, the graph will be reflected about the x-axis, and then the period will change from 360 to 180. Okay, so yeah, cos 2x. So that's how it will be. And then starting at negative 180, ending at positive 180 in intervals of 45 degrees. Okay, so at negative 180 we have negative 1. All right, negative 135 we have 0. Negative 90, it's 1. Negative 45, 0. 0, it's negative 1. We're starting to see the trend over here. 45, 0. 90 should be 1. 135 is 0. 180, I'm expecting negative 1. Okay. So cool, there we have our graph. Okay, cool. Now it says write down the period of 2g x plus 10. How? What's this now? 2 times g. And it has moved, or it has shifted 10 degrees to the left. And now we have 2 times g. Okay, let me just write this down. So 2, and then g is negative, and it's only 1 mark, but I just want to write it down for myself. Negative cos 2x. Okay. And then the x plus 10. So this is like shifted. Yo. But anyway, let me just not even bother with everything else. The period is affected by the coefficient of x, and the coefficient of x is 2. So like I said previously, original function cos x, the period is 360, but now because we have 2x, the period will be 360 divided by 2, which is 180. Yeah, let's not complicate our lives. We'll see. And it says use the graphs to determine the values of x in the interval of 0 to 180 degrees, for which the values of f times the y values of f times the y values of g are smaller and equal to 0. So they'll be small. Let's say if f is negative and g is positive, then they'll be small and equal. Or if f is positive and g is negative, then they'll be smaller and equal to 0. So let's use different colored pens. We're basically going to focus on areas where they have different signs. So here we see that it's both negative. Here we have 0 and negative. So yes, this is something we're going to consider. Here we have positive and 0. So yeah, we're going to consider 90. We're going to consider negative 135. Then we have 0. Okay, here it's positive and positive, so we're not really going to look at that. And then we go all the way up. We have 0 and positive, so negative 45 we're also going to look at. And then we have, okay, let's do it like this. Yeah? So they said smaller than or equal to 0. So we can see that x in between negative 135 and equal to 135 up until we get to negative 90. Let's note that. Okay, so it's in that region. And then what else do we see? It's both positive until we get from negative 45 all the way. So this is positive, that's all negative until we get to 45. Okay, and then from there they're both positive until we get to 90. So 90 all the way to 180. Okay, so yeah, that's basically that. Oh, they gave us from 0 to 180. Ooh, yeah. But anyway, it's fine. We were able to determine the areas. And now from 0 to 180, we can say 0 up until, so x. Okay, so we're from 0 up until 45 degrees. Okay, and then what else do we have again? We have from 90. Did I just say up until 180? No. From 90 until 135. Jeez. Okay. So we have from 90, because this side is positive, and then this is 0, this is 0, that's negative, and then from there, they're both negative. Okay, so now we have from 90 to 135. All right. Okay. Yeah, not 180. And that's it. So now 6.4 says, write down the maximum value of f of x minus g of x. Okay, I didn't label the graph. So this is g. Yeah, and that's f. So let's see, f of x minus g, the maximum value. I would say it's here because f is 2 and that is minus 1. Okay, other than that, the spacing in between, you normally get 1. So here it's 1, there it's 1, 1, then there it intersects, then it gets a bit bigger, and then until we get here. So yeah, so f of x, we have 2, and g of x, we had negative 1, right? So 2 plus 1 is 3. Okay. And then 6.5, last question. Determine the range of y is equal to 2 to the power 2 cos x plus 2. Oh, okay. Let's see. Yeah, this is a challenging one. So if we're looking at 2 cos x alone, our amplitude is 2, right? So it would, if we were to draw our graph, it would basically start at 2, the maximum 2, minimum negative 2. Okay, so the range for 2 cos x is basically from negative 2 to 2. All right, and then if you look at 2 cos x plus 2, we have shifted the graph 2 units upward. If we shift it up, our range, 2 cos x plus 2, taking it step by step, our range will go from 0 to 4 because we've shifted it up 2 units. And now, so we've dealt with 2 cos x and 2 cos x plus 2. And then, now let's look at 2 to the power 2 cos x plus 2. Okay, so there we're going to say, because this is really what we're focusing on, okay, yeah, all those errors. So basically we're going to look at 2 to the power 0 and also 2 to the power 4, because we've established that it's applicable there from 0 to 4. So 2 to the power 0, that's 1. Anything to the power 0 is 1. And 2 to the power 4, that is, I think, 16. Yeah. So basically, that's that. Thank you for tuning in. I think my husband will take over from question 7 onwards. Or maybe I will. I don't know. But yeah, definitely this paper slower than paper 1. It's not as bad as I thought, but as I'm doing the questions, this is the first time I'm seeing them. I'm not as prepared as the others where I do it before I record. So here I'm just like, oh my gosh, I'm seeing this question now. Let's see how we can deal with it. But yeah, see you later for question 7. Question 7. The diagram below shows 2 vertical poles. AD, okay, you can see it here, and BC. Point E lies on the same horizontal plane as bases D and C of poles AD and BC. Okay, so this is on the same, it's like at the bottom. All right, so angle E in AEB is 2 alpha. All right, and then angle E in BEC is alpha. Angle B in ABE is 90 minus 3 alpha, and BC is y meters. Okay, so determine BE in terms of alpha and y. Okay, so what I like doing, I like drawing out the triangles so that I see what exactly it is that I have. Okay, so let's start with AEB. Okay, so there's a triangle there. We have A, E, B. So that is 2 alpha. And we know that B is 90 minus 3 alpha. Okay, don't really have much space there. So we can get what A is if needed. Okay, but we are looking for BE. So there is BE. But anyway, if we look at BEC, we have a right angle triangle. So that is B, that's C. Okay, what happened now? Okay, it's a right angle triangle, and then we have E. Okay, and we know that BEC is alpha. Okay, so I think that is where we will start. In terms of ABE, there we have it, and then BCY. Yeah, so in terms of this right angle triangle, we can use that to determine what BE is. All right, and we can use sine. So if we say sine of alpha is equal to y over BE. All right, and in terms of BE, if I bring BE onto the left-hand side and divide by sine, I'm going to get y over sine alpha. And that's it, 2 marks. Now it says show that AB is 2y. So this is AB over here. Okay, so I think somewhere, somehow, we might use either the cos rule or the sine rule. Let's just see what we have. So, all right, for 5 marks, show that AB is 2y. Okay, so where do we start? I would say we just determined BE, right? BE is y over sine alpha. And if we're looking at this triangle, AEB, so we have 2 angles, angle B, angle E. We can get A by saying 180 minus B and minus E. If we really wanted to. And we have one side, and we're looking for AB, right? Okay. This is what we're looking for, I think. Yeah, I think we can use the sine rule. I think because we have a side and the opposite angle, and we're looking for a side and we have an angle. Okay, yeah, so I think let us then use the sine rule and see how far that will get us. All right, but in terms of getting A, let's just get A for now. All right, so we're saying A is 180 minus E and minus B. Okay, what is E? Remember, E is 2 alpha and B is 90 minus 3 alpha. Okay, 2 alpha, 90 minus 3 alpha. Okay, so let's just work that out. We have 180 minus 2 alpha minus 90 plus 3 alpha. So 180 minus 90, that's 90. And minus 2 alpha plus 3 alpha, that's just alpha. Okay, so we have A. Now we can use the sine rule and say AB is what we're looking for. So AB over 2 alpha is equal to y over sine A divided by A. Okay, so AE over E and BE over A. Okay, so we have AB over angle E is equal to BE over angle A. Okay, and we know that E is 2 alpha. AB is what we're looking for. Actually, let me take E to the other side. So we have BE times angle E over angle A. All right, so BE, we solved it. It's y over sine alpha. Angle E is 2 alpha. And angle A is 90 plus alpha. Oh, snap. Sine. Thinking, what am I going to do? How am I going to cancel all of this? Okay, so we have sine and we have sine 2a. Ooh, we have little space, but we'll work it out. Okay, so therefore I have AB equal to, so I have y over sine alpha times 2 sine alpha cos alpha. And at the bottom, I have sine 90 plus alpha. 90 plus alpha is in the second quadrant, and sine is positive there. And then the sine and the 90 turn this into a cos. So I can already cancel the causes, right? And also sine. So then I have y over, no, I have 2y. I almost said y over 2. So there we can see that AB is actually 2y. It is further given that AF is 7 over 4 BC. Determine BAF, the angle of elevation of B from A. Give your answer to the nearest degree. Okay, so AF is 7 over 4 BC. Let's have a look. Okay, that's AF over there. 7 over 4 BC. Remember BC is y, right? So 7 over 4y. And we actually have a right angle triangle. Okay, so that is your angle A in BAF. It's a right angle triangle. It makes things a little easy. So if I'm looking there, I see I have adjacent over hypotenuse. So I'm going to use cos, right? So cos BAF is AB over AF. No. AF over AB. Okay, so cos BAF is equal to AF over AB. All right, and we know that AF is 7 over 4 y, and we know that AB, we just solved it there, it's 2y. Okay, so 7 over 4 divided by 2 because the y's will cancel. We have 7 divided by 4 over 2. So we have 7 over 8. All right, but remember, we still have the cos. We need to solve for the angle A. So BAF okay, so shift cos, answer, and we get 28.96 degrees. But they said give your answer to the nearest degree. So that's going to be 29 degrees. Okay, and that's the end of question 7.
Okay, let's look at question number 8. It says in the diagram below, the circle passes through points A, B, C, D, and G. AD is a diameter. Okay, AD is a diameter of the circle. BD and AC intersect at H. Okay, I see that. And then the angle AGC is 58. All this information is shown on the image below. Okay, so here's the first question. Determine, giving reasons, the size of the following angles. The first one is B2. Now, using the clue that they gave us of a diameter, remember they told us that this is a diameter right over there. And then if we go to the B, you see B2 over there, and look at that triangle right there. Okay, what do we know about that? We know that actually the angle B2, so B2 is just gonna be equals to 90 degrees, and the reason is because of angles in a semicircle. Okay, angle in a semicircle, that's it, or angle of a diameter. Okay, there we go. All right, so the next one is B1. Okay, what clue do we have about B1? Where's B1? There it is. Okay, so what I'm gonna do is just rub this so that I can go to the next thing I can look at. Obviously, with these questions, there are a lot of things you can look at, but some of them are just obvious. Let's go see. The next clue here was this AGC. Let's use that. So if we look at this cyclic quad here, which is completed, that's the cyclic quad we're looking at. Do you see that actually if we are looking for B1, okay, what are we looking for? B1. We're looking for B1. What we do know is that when we add up all these angles, the opposite angles are supplementary in a cyclic quad, which means if I'm going to say 58 plus B1 plus B2, that should give me 180. Okay, so let's write that down. Actually, what I'm saying B1 plus B2 plus the angle G is equals to 180. And what's the reason? It's opposite angles of a cyclic quad. Okay, so it's opposite angles, which is gonna do that, of cyclic quad. That's all you had to write. It's opposite angles of a cyclic quad. Now I can substitute. B1 is what I'm looking for. B2, I have it, it's 90. G, I have it, it's 58. is equals to 180. Now all I have to do is mathematical gymnastics. So B1 will be equals to 180 minus 90, okay, minus 58, just like that. And then we bring out a calculator. Let's get this calculator. Oops, why is it on this? Okay, so if I am to move it there so that I can see the number, it's going to be 180 minus 90, like that, minus 58. It's gonna be equals to 32. So B1 is 32. So there we go. Final answer. B1, okay, is equals to 32 degrees. There we go. 32 degrees. All right, so now we're looking for A2. Okay, let's rub this clue, what we highlighted here. We no longer need it. Now we are looking for A2. Okay, what can we use? Normally, these questions follow each other in such that the previous question helps you to solve the next one. So now I've solved B1. Now, if I look where B1 was subtended from, so I start there at B1. This is the angle B1, right over there. Okay, and it's subtended by DC, the arc DC, or the segment DC. Also, that same arc subtends A2. So that's what we're looking on. You can now write it down that actually I can see that A2 is equals to what? Is equals to B1. Okay, and the reason is because these are angles on the same segment. Angles in or same chord, it's up to you, but in same seg, same, which is complete the English there, same segment. Let me wrap that, write it nicely, same seg. Okay, just like that. So then therefore A2 is equals to what's B1? It's 32 degrees. Okay. Oh, here the first one I forgot to put degrees. Okay. Now let's continue to the next question. Okay, so if we look at 8.2, it says if it is given that AB is equals to BC, prove that AB is a tangent to the circle passing through A, H, and D. Okay, so we need to go highlight this things. So if I go back to the circle here, I said the circle actually is, first of all, let's highlight the tangent. The tangent is AB. Okay, they want me to prove that this tangent is actually, okay, now I want to draw the actual circle. They said it's passing through A, and then it goes to H, touches H, and then it goes to D, and then it comes back to A. So that's the circle. So if we are going to prove that it's a tangent, we need to prove that the angle between 10 chord theorem, the angle between the tangent and the chord, which is that angle there, is equals to, maybe let me do it in a different color. I'll use this sign. The angle between the tangent and the chord must be equals to the angle opposite that chord, which is D. So this is what I have to prove, that these two are the same, Okay, so first of all, they told me that AB is equals to BC. So if AB is equals to BC, there's BC, that means it's an isosceles triangle, which therefore means that if I look at the angles, C1 is equals to A3. They're the same angle. All right. But also C1 is equals to D because of the same segment. They come from the same seg, which is AB. You can see they're subtended from the same AB segment. But let's write it down nicely so that it makes sense to you. So first of all, I said C1, if you remember, C1 is equals to, what was that other one? A3. And what was the reason? The reason was because of it's an isosceles triangle, but saying isosceles triangle is not the reason. The reason in this case is opposite angles. It depends what you're talking about. If we're talking about angles, then we say opposite angles, okay, equal sides. Equal sides. Opposite angles equal sides. That's the real reason. Or angles opposite equal sides. You can also equal sides. You can also say that. Okay, that's the first thing we said when we're talking about this. That C1 is equals to A3. The next thing we said was that C1 is also equals to D. And what was the reason there? Angles in the same seg. But also C1 is equals to angle D. And the reason there was angles in the same seg. We're just going to write same seg. Okay, but you can write it in full, angles in the same seg. And that segment, I actually want to write what that seg is, so that it's clear. Same seg, C1 comes from the segment AB. That's the chord. So, AB. Close it. Okay, now, therefore, I can conclude and say, A3 is equals to D. And that's exactly what we wanted to prove, because this is now a converse 10 chord theorem. A3 is equals to D. That's what we're trying to prove. A3 is equals to D, and therefore we're concluding now. AB, you write the statement according to the question. AB is a tangent to the circle. Okay, and the reason is because this is now a converse 10 chord theorem. 10 chord theorem. That's it. All right, let's look at question 9. It says in the diagram below, O is the center of the circle. Cool. point ST and R lie on the circle. QS is a tangent to the circle at S. Okay, I see it. Then it says use the diagram above to prove that the angle between the tangent and the chord is equals to the angle in the alternate segment. That is, prove that QST is equals to R. So they want me to prove that this angle over here, that's QST, is equals to the angle R. Okay, there are many ways I can do this, but the one that is taught in metric is this one. First, you need to construct a diameter from S, okay, if you can see, passing through O all the way up. Remember, a diameter must touch there. And then also from R, I'm going to extend to that same point there. What shall we call this point? RSTU. Let's call it U. Okay, so now what we're going to say is, first of all, let's look at let's highlight the diameter itself. Okay, so it's going to be there, there, and there. And what do we know about that whole angle of R? We know that that angle actually is equals to 90 degrees. We can actually talk about it, and we're gonna call it SRU. So angle SRU is equals to 90, and the reason is because angle in a semicircle. Let's write that down. Angle in a semicircle, or you can just say angle subtended by diameter. Okay, all right, so we've established that. What else is equals to 90? We know that this angle also here, okay, so let me just put that 90 right now. We also know that this angle here is 90. Why? Because of the relationship between a radius and tangent. Okay, they're always 90. So I'm gonna say QSU is equals to 90. And what is the reason? It's the relationship between the radius, and the relationship is such that it's perpendicular. The radius is always perpendicular to the tangent, always. That's the rule. Always perpendicular. There we go. Now, can you see that if both of them, that those 90s, they have these little angles, okay, inside of them. So what I'm going to do is, now let's look at the angle Q, because okay, let me wrap this because I want you to see this very clearly. I don't want you to miss this next part. So let's wrap everything because it's a little bit dirty now. And then let's start again. Do you see? Now I wrapped it too much and I need that construction. Okay. All right. So I'm just gonna use it as it is. It's fine. Do you see that the angle, actually these other angles, I'm just gonna draw it in red, URT, and the angle UST, they both come from the same segment TU. So I can actually say Well, if I look at the angle U R T, this is a URT, this angle is actually equals to the angle UST. Why? Because angles are from the same segment. So angles from same segment or same chord. And what's that chord? TU. Okay, so if those are equal, therefore, okay, because now I've identified that this angle right here, I want it in red, this angle right here is equals to that angle right there. Okay, which means these other two angles must be equal, because if you subtract the red angle from 90, they will give you the same answer as shown here. So I'm just gonna rewrite it as shown in the question. They said Q ST, so I'm gonna write it like that. Q S T is equals to the angle R. Okay, therefore, and that right there is the proof that they wanted. I'll stop right there. Okay, let's look at this next question. It says in the diagram below, D, E, and F are points on the circle centered at Q. Okay, so Q is the center. A, G, F is a tangent to the circle at F. Okay, I see it. ED is produced to meet the tangent at A. I see it. B and C are points on AE such that GB, where's GB? Oh, I see GB is parallel to FD. Okay, it's shown as well. GC is joined. GCDF is a cyclic quad, and FQD is equals to 2x. Now, I want to highlight this cyclic quad because if I don't, I know I will forget it. So what is it? It's GC, and then D. There we go, D and F. Okay, so just like that. That's a cyclic quad, even though they're not showing they're not showing the circle, but they're telling us it's a cyclic quad. Okay, let's see if we'll need it for the first question. First question is give a reason why angle E is equals to X. Okay, let's look at that. First of all, let me wrap this. Now I have it in memory that it's a cyclic quad, so I'm all good. Now I want to highlight what we're talking about. Okay, so give a reason why E is equals to X. There is angle E. Why would this angle be equals to X? Because if you look where it comes from this segment, FD. But FD also goes to the center. Okay, so the reason is that which we call, do you remember what we call it? Angle at center is twice the angle at the circumference. So you're just gonna say angle at center. Okay, spelling of center has a R first. Center is actually equals to twice or 2 times angle at the circumference. Circumference. Okay, you write it in full. Okay, let's look at the next question. Prove that GC is parallel FE. Okay, let's go and highlight these so that we can see a proper picture of what it is that we are talking about. So I'm gonna wrap this, then I want to highlight the next batch. So they said prove that what was it? GC and FE. Okay, let's go back. GC, there is GC, and FE, there is FE. I have to prove that these two are parallel. Okay, let's start here. I know already that this is angle X, E. But what else is E equals to? Okay, this is angle X. E is also equals to the tangent, this angle in the tangent. So I'm saying this angle here is equals to the angle there. It's the 10 chord because of the 10 chord theorem. So the reason I'm doing that, you'll see as so let's just start there. You'll see why I said that. And I said the angle E, oh no, not this color, let's go black. So I was saying, if you look back, the angle F1 is equals to E, which is equals to X. So F1 is equals to E, which is equals to X. Why? I'm just gonna write it in full. 10 chord theorem. 10 chord theorem. That's why. It's because of the 10 chord theorem, and this is F1 is equals to X then. Okay, now let's see. Okay, so now we are going to need the actual cyclic quad, because what the next point I want to show you is that if you look at this cyclic quad that they told us is a cyclic quad, it was this GCDF. So according to cyclic quad, this angle here, let me not highlight, or let me highlight this angle here. Okay, this angle is equals to F1. Why? Because of external angle of a cyclic quad. So that's C1. Okay, so we know now that actually C1 is equals to F1. Why? External angle of a cyclic quad. Did you see it? Cyc quad. Okay, so F1 we establish is also equals to X. Now, if I am to rub all of this, okay, so that you can see it properly, let's just erase because now it's all dirty. I want to be left with the original parallel lines. Now, if you look at that, and we have established that C1 is X as well, you can see that this, if I'm to draw, this makes a line, and you can see that this X and that X there is what we call corresponding angles. Now we've proved corresponding. Since C1 is equals to E, those are corresponding angles. So then we can conclude, therefore, and say that, well, since C1 is equals to E, so C1 is equals to E, okay, therefore, GC, which is the question that they ask us, is parallel to FE. Okay, and why is this? Corresponding or converse corresponding angles. Let me just say corresponding angles. Why? Corresponding angles. These are corresponding angles, just like that. COR are angles. That's it. Okay, let's look at 9.2.3. It says prove that AB over BD is equals to AC over CE. Let's go take a look at those variables. Okay, so they said AB over BD is equals to AC over C. Okay, I see it. All right, let's start this one triangle at a time. This is proportional triangles. Remember, for proportionality theorem, you kind of need parallel lines for it to work. So let me highlight the most obvious ones that they gave us in the question. It was this one and also that one. Now those two, if I'm to complete the triangle, they come from A to F to D. Okay, so I look at this triangle, I can see that AB over BD is equals to AG over GF. I can see that, so I'm gonna write that down. Okay, what was it again? It was AB over BD. That was equals to AG over GF. Okay, and the reason for that is proportionality theorem. So I'm just gonna write prop theorem. It's what it says. Proportionality theorem. Okay, now I'm done with that one. Remember, on the previous question we were talking about proving that these other lines are actually parallel, GC and FE. Remember, we spoke about that. That's the next thing we'll be looking at right now. I want to highlight those two. So let me just rub these ones, these two. Okay, so now I'm looking at the new highlights will be GC. We concluded that these were parallel, is parallel to FE. Now let's complete the triangle. Okay, so you can now see again, AG over GF is equals to AC over CE. Yeah, I've crammed it. Now let me go write it down. Okay, so now we are saying, oops, make it a little bit bigger. So now I'm saying that AG over GF is now equals to AC over FE. Okay, so since both of these are actually equal, you can see that they have AG over GF equal. These two are literally the same. Okay, literally. So I'm going to conclude that whatever they are equal to are actually equal. And that was the question. Therefore, I'm going to say AB over BD is equals to, but I'll write it like how they did in the question. They said AC over CE. Oh, they said CE. Did I make a mistake here and said FE? I meant CE on top. This is CE, not FE. This one. We can actually go confirm it. Because I was cramming this thing, I thought I'd remember. Yes, it's AC over CE. Yeah, that's the one. AC over CE. Let's write that down. CE. So this is over CE. That was the question, by the way. So, which means we are done. Oh, also the reason for this one, same reason. Prop theorem. You must always give a reason for why you calculate things the way you are in Euclidean. Okay, let's leave it there. Let's go to the next question. Okay, let's look at 9.2.4. It says it is further given that AB is 12 units, CE is 22.5 units, and 5AG is equals to 4GF. Determine the length of CD. If they say it is further given, that means we are definitely going to use what we were doing upstairs on the previous question on this particular question. So remember, we established that actually the parallel lines, these ones, they give us that AB over BD is equals to AG over GF over GF, just like that. Remember, we use that. So what information do we have? We actually have information right here about the relationship between AG and GF. So what I'm gonna do is that I'm just gonna write it on the side here and cross multiply these two, okay, such that they give me that AG over, if I cross multiply GF, on the other side I'll be left with 4, and then I divide by 5. Okay, so all I did is cross multiply so that I have variables on one side and numbers on the other side. So this means now that when I come back here, I'm gonna say all of this is equals to 4 over 5. Okay, over 5. Okay, now that's using these two lines. Now I want to do the same, but let's go look at the other lines. And the other one, parallel ones, was GC was parallel to FE. Remember those? And what did that give us? That gave us that AC over CE is equals to the same thing. Okay, so this time it's AC over C, what's that, E over CE over CE is equals to the same AG over GF, which is actually equals to 4 over 5. That's it. So now what that does is that I'm now able to substitute the numbers associated with this. I'm given AB is 12 units, so I'll start right there. I'm going to say, okay, I know now based on what I'm given that actually AB, I'm just gonna write 12 because AB is 12. I'm going to the first condition there, over BD. I don't know what BD is. That's what I'll be solving, is equals to 4 over 5. Why am I doing this? Let me show you why. This first one is that I'm going to solve is BD. I'm going to solve BD. Let me just highlight it. I'm going to solve BD right there. And then the second one, from the second one, what am I going to solve? From the second one, let's see what I'm going to solve. Let's just write it down first. Second one, AC. Am I given the units of AC? No, I'm not. So I'm going to go AC divided by CE. CE I'm given, it's going to be 22. So I'll just write that down. It's 22. It's 22.5. Okay, that's equals to the same 4 over 5. I'm using the second condition over 5. So here I'll be solving for AC. Now let's go and highlight AC. AC is actually from here to there. Remember the question wants the determine the CD. Okay, so if I'm to solve AC and then I solve BC, I can effectively subtract them both so that they give me the final answer. Not BC, man, it was BD. I highlighted BD. That's what I'll be solving for. Okay, so let's continue and see what is going to happen over there, because BD, and then I'm going to want BC. Ooh, these things get confusing sometimes, but let's just keep working it. We'll do it one step at a time. Okay, now let's solve what we can. So if I cross multiply here, I'm just gonna go straight to the answers. So BD, just do your mathematical gymnastics. We'll use a calculator. We're going to say to solve BD, I'm gonna cross multiply. Let's just see the numbers. If I bring BD, it's gonna be 12 times, all right, 12 times 5, and then divided by 4 to get the length of BD. So BD is going to be 15 units. Okay. And then AC, I'm going to do the same. I'm going to cross multiply to solve for AC. Okay, so it's AC, and that's going to be equals to, if I cross multiply, it's going to be 4 times 22, 4 times 22.5, and then divided by 5. And we'll get AC is 18. This pen sometimes dribbles. My wife is the one who's an expert in using this pen, but not me. Okay, so now, thank you, calculator. So now we have solved both of these. What I can say is that BC is going to be equals to AC minus AB. We are given AB, it's 12 units. Do you see it? If I say AC minus AB, I will have the length of BC. And then I will use that length to find the length of CD. I'll subtract it, but that one step at a time. So I'm going to say AC minus AC is 18, but let me write it down. AC minus what am I given? AB. AB. This will give me what? AC, it will give me BC. BC. Okay? BC. Now let's put in the numbers. AC, we just solved it, it's 18. So it's going to be 18 minus AB is given that it's 12 units. 12. Now what is 18 minus 12? I can do that in my head. It's definitely going to be equal to 6. Both of them are multiples of 6. Okay, now that I have BC, if you look at it, look at where BC is. I have BC, and I'm looking for CD. So, which means BD minus BC will give me CD. Alright, let me just write it down first. So, I'm saying to get the final answer for CD, that's going to be equals to, the longer side is BD. It's going to be equals to BD. Alright. So BD minus, subtract the shorter side that we just solved now, which is BC. We just solved BC now. So BC. Come on, pen. Now let's put the numbers associated with it. BD, we know BD, we solved it. It's 15 minus BC. Okay. Let's check if it's correct. BC, we just solved BC. It's 6 units. So my final answer is equals to, so this is CD. What is 15 minus 6? That should be 9. So final answer is 9. This thing is failing me. This pen. So the final answer is 9 units. You must always write it Always write that word units at the end. Units. There we go. Okay, let's look at question number 10. In the diagram below, K, H, and G are points on the circle. I can see them. There they are. And FG is a tangent to the circle with the center E. Where is it? Oh, there it is. Semicircle with center F is drawn. I see it. Points D and E lie on the semicircle. Okay, I see them. CD and CE are tangents to the semicircle at D and E respectively. And then CD is parallel HE. It is also shown on the diagram. Okay. So first question says, give reason why DC is equals to EC. Now, if you look at the individual, highlight DC and then highlight CE or EC. Why? The theorem here is because it's tangent from the same point, and that point is C. So you're just gonna write tangent with the S from same point, and that point is obviously C. Okay. Next question says, prove that triangle DCE. Okay, let me just highlight DCE. It's that triangle is similar to triangle HEK. So there's H, HEK. These are the two triangles that I'm trying to prove that they are indeed similar. So whenever we prove that, we actually have to show that this first D is equals to the first H in that triangle. Okay, so the D is equals to the H. What is this pen doing? That's what we have to show. And then we have to show that C is equals to E, and that E is equals to K, like that. So we kind of look at which one will be the simplest first. Now, looking at these two triangles, what connects them is this chord CE, and you can see that I've got two parallel lines. So the angle C from the big one, I'm just going to say that angle C is equals to the angle E, and the angle E in the red triangle is actually E2. Okay, so that one is pretty much the easiest one to pick on. Now let's go back and look what's the relationship between D and E. Is there a relationship that's obvious? D and E, there's no obvious relationship. What about the last one, E and K? E and K, there's no obvious relationship there. Okay, it would have been nicer if DE was actually parallel to KH, but it's not. So, but there are other tricks that we can employ. So let's just go back to the first one. Now here we are dealing with parallel, not parallel, but an isosceles triangle. Let's look at the green triangle, DCE. And from there we can see that actually E1 plus D plus C is equals to 180 because of angles in a triangle. Let me write that down. D plus E1, okay, plus the angle C is equals to 180. This is because of sum of angles in a triangle. So I'm just going to write angles in a triangle. Okay, but now you can actually see that E1 is equals to D because it's an isosceles triangle, but that's not the reason. The proper way to write it is to say angles opposite equal sides. Okay, so I'm just gonna say but D is equals to E1 because angles opposite equal sides, like that. Okay, so that means D plus D, which is 2D, is equals to 180. Yeah, that's like me just solving for D. 180 minus the angle C. Okay, minus the angle C. Now let's go to the red triangle. Do you see that also I've got red eye there? EH and EK are both red eye, which means there's a relationship between K1 and H. They are the same, and when I add up all these, they make 180. But let's just write it like we did above. So I'm going to say H plus E2 plus, what's that one? K1. K1 is equals to 180. All right. And why is that? Same reason as above. Angles in a triangle. These are angles in a triangle. Okay, but we can see that H is equals to K1. Okay, H is equals to K1, which means in that equation, in the equation above, I can just say 2H is equals to 180 minus E2. Can you see it? Minus E2. Let me finish that 180. 180 minus E2. Okay, so you see that. But now I want you to focus on this. I want you to focus on this. 2D, 2 is the same as that 2. Then I have D and H. Then I have this 180 and that 180. Then I have a minus and a minus. All these things are the same. And also C and E2 are also the same because I proved it up there. Okay, I can actually write it down if I want. I can say also C is equals to E2. This has been proven above. I'm just going to write proven. Which means, just to finish the highlight, C is equals to E2. Therefore, you see everything I highlighted are the same, including this equal sign. It's all the same. The only things that are different are the letters D and H. Therefore, I can now conclude and say, well, if everything else is the same, therefore, D must be equals to H. Right? Do you see that? So now I've proven that D is equals to that H. I've proven that C is equals to E2. That means the last ones missing is E1 is equals to K1 as a third angle. Okay, it's a third angle. And also third, let me just say, what was it? K1. The missing ones. It was E1 and K1. So E1 is equals to K1, and then I'm just gonna say third angle in a triangle. Okay, and therefore, since all of these are equal, I can conclude that therefore I'll write it exactly as they wrote it in the question. Triangle DCE is similar to triangle HEK. Just like that. Let's move on to the next question. Okay, let's look at this question. 10.3. Prove that DG is equal to GE. Let's go check them out. Prove, let's highlight them first, that DG is equals to EG, like that. Oh, okay. All right, let's start here. Now, if you look closely here, we know that this line is a tangent. We have been told that it is a tangent. We also know that this one is a radius. And do you remember the relationship between a tangent and a radius? Yes, they are perpendicular. And if these are perpendicular, then it means, and this line is from F is from the center and it's perpendicular, that means this line bisects the chord. The line from the center bisects the chord, meaning DG is equals to GE. Now we just have to write it down. Let's see how we're going to write it down in a format that is understandable. Okay, now if you remember closely, we said that angle, what was it? EGF is 90 degrees. So the angle EGF is equals to 90 degrees. Why? Because of the relationship between a tangent and a radius. So it's a tangent is always perpendicular to the radius. That's the rule. And since they are perpendicular, that means it's actually, we can conclude already. That means that DG is equals to GE, and this we spoke about, that the line from the center, the line from the center is always going to be perpendicular to the chord, That's it. It's just two lines like that, and then we are done with that question. Okay, let's look at this last question, and it says show that 2he squared is equals to dc times hk. Whenever you see these questions, you must know that it's always a question of proportionality, and we're going to use the triangle probably given in this question. So what I'm gonna do, I do what I call a frog face, where you have to show that dc over he is equals to ce, right, over ek, which is equals to ce over hk. Kinda looks like a frog, doesn't it? Well, if it's drawn properly, it does. But anyway, dc over he is the first one. So dc over he is equals to dc over he is equals to ce over ek. So ce over ek, which is also equals to the last one, de over hk. de over hk. Now we will take the relevant one that we probably need. We need the one with he, definitely, so we are taking this first one. I'm going to use it, and then the other one is the one with dc. Is anyone with dc? None of them have dc. What about hk? Does anyone have hk? This one has hk, so we will take this one as well and combine them, and hopefully we can work it out. So what we'll do is cross multiply. I'm going to say dc times hk. This side, I'll just cross multiply. The first one is dc times hk is equals to, is equals to de. I'm just cross multiplying times he. Okay, well, if it doesn't look like a times, let's make it look like a times properly. This one, it's the pen, times he. Okay, so from there, what can we do from there? I already have the first portion, which is dc times hk. If you look here, dc, this portion, they are exactly the same, which means I need to manipulate that. What is the relationship between de and he? Let's go check it out. de, where's de? de is that, and hk and he, sorry. I need a relationship between these two. Well, I can actually see that he is also equals to ge, which means ge is equals to eh, and also de is twice ge, because remember we said it in the previous question, that's this is equals to that. That's why they were asking us that question. dg is equals to ge. So now, and de is twice ge. Okay, so let's write that down. So this is going to be, like I said, if I can remember, de is twice he. So I'm gonna say 2 times DE is 2 times HE. Should I write it like that? Or should I just, let me write it. DE, remember, DE was actually twice GE. Let's start there. Twice, no, let me just say HE. 2 times, okay, but let me say but first. But DE is equals to 2 times HE. And the reason is because of the relationship between a radius and a diameter. DE is a diameter, HE is a radius. You see, DE is a diameter in this. No, actually, it's not a diameter. Let's just say because GE and EH are both diameters, are both radii. Okay, so that's the reason. Both of them are radii. Okay, I'm just gonna say GE and HE are radii to that circle, Okay, so then if I am to rewrite this there in one, okay, let me not confuse you. Let me just write it, not skip steps. So 2HE, I'm just swapping them around, times HE is equals to DC times HK. Okay, and then finally, therefore, 2HE squared is equals to DC times HK. That's it. We have done the proof successfully now. Well, we've come to the end of this paper. I sure hope you learned something today, and all the best with your next assessment. This is from me, and I'm saying goodbye.